What this project is about is statistical distance and analysis of when firms need to go and seek outside funding sources or keep their project in-house as far as funding it internally. So reasons we found in our consulting group for outside assistance needed were mainly these are the significant ones. There's several others, but these are just the main ones we kept covering into. Certain divisions of firms might be financially restrained, couldn't have the funding, or depending on the year, the cost, the amount of the project it was, they didn't have the money to charge it. And also almost all the time larger budgets ended up needing outside assistance. Movies made under alliances or multi-firms also usually earned more. That was significant. High-risk projects almost always outside assistance was needed, or lower forecasted projected profit, and resolving contracting issues in internal capital markets. So this is the opposite. Internal financing, no outside assistance needed. The firm, usually these factors came up. The firm might not have necessary capital to put the money down. The rate of return on the average was greater, and the higher margin and lower p-values usually signify that the firm only financing. Also, low risk project, which is the opposite of what was mentioned before. Historical data for the following graphs are usually from past film funding and other entertainment projects. And also data consisted of moving rate analysis for G, PGR, PG-13 sequels, and other risk-related factors. So summary statistics usually end up saying the average movie in our group consulted costed around $50 million, while the average median was about $150 million. So showing the average rate of return was about 106%, while the median rate of return was about 40%, showing that most movies are highly profitable with those returns of 40% and 106%. So looking at standard deviation right here, 188 million was the total revenue versus the total cost of 47 million, and our budget was 35 million in most of our data of the standard deviation. In a median analysis, the statistically see we would always see negative on the times we would see negative values, as shown right here. Then the budget, revenue, and cost, usually below the overall means, which would lead to multi-firm financing, while the total returns and the return would have a high p-value, also trending to multi-firm financing. But the positive z-values, as you see right here, 0.54, usually showed greater return when only firm only financing, no outside funding was needed. As you can see, 1.4, a little bit higher than the multi-firm greater return. So the above average rate of returns on firm only financing, but with the total revenue being so high, more multi-firms coincide with the p-values. So basically, where the p-values were significant, which you can see the budget and total cost, that ended up being a little bit better data to analyze. And the means analysis, the means comparison suggested that more expensive movies, more movies that cost more, tended to seek the outside funding, as mentioned earlier. And also, what I want to show is the t-values, when you had high t-values for the cost and the budget, and for the films, these I would show that the more expensive movies would seek the outside funding, because you can see here the higher numbers for the multi-firm compared to the firm-only financing. So then the higher revenues right here on the multi-firm do not seem to justify the extra cost, because the difference in the rate of return turned up being not significant. So the high p-values on the rate of return and the revenue and rate, as you can see right here, the revenue and the rate, with a low t-value, same thing, basically showed that those weren't statistics to go by, because the budget and costs, the same as mentioned earlier, are more significant to go by because p-values are good. And so we would use a lot more of the data, the budget and the cost side of it, when we were doing our analysis, putting everything together. And the probability, so when we put all that data together with means, median analysis, all that, build some type of graphing structure here. We looked at the marginal effects of the p-value. So what we came up with in the 02 and 07 years, those had high p-values, or good p-values, let's just say, with high marginal effects, and so those weren't many multi-firm, it was more internally. But then in 05 and 06, they also had low marginal effects, just the opposite, and had high p-values, thus many multi-firm financing. So it's just the opposite effect was happening in 05 and 06. What I wanted to show, that main significance of it was the overall project risk had a good p-value and below average marginal effects. This signified that it showed a tilt towards most overall multi-firm financing when you're comparing the marginal effects, other than those few years here and there that was pointed out. But then the budget good was good for both categories, showing good overall analysis, and a good graph is shown right here. So when you're looking at the profitability regression we did, the main things in the profitability regression, we came up with the 02 and 03 had low p-values and a high estimate, showing the firm-only financing and good potential profitability. So you can see here the low p-values. But then 04 through 07, outside funding was needed more often. Multi-firm financing turned up being lower profitability, but we had, the R-squared we didn't really like at 0.30. It ended up being low, so we were worried about that. But then the negative budget, with that being negative budget, had a really good p-value, and so it usually showed the lower forecasted profitability. But the only thing is that with it being so reliable with the really good p-value, the 04 through 07 years, because there were so more outside funding was needed, the budget usually ended up being on track for all those years. On the revenue regression side, this also ended up having a pretty good line that was going through our data. As shown in the negative values in 06 and 07, more movie projects usually end up also needing outside funding sources. In the 02 and 03, as similar to the studio projects were financed within the firm, as seen because of the high revenues and low p-values. So parameter estimates were a lot higher, as you can see here, in low p-values. So the 02 and 03 usually end up being the internal financing. And this is really good because adjusted high-square at 0.50 was some of our better data, and the budget had really good positive numbers with good p-values. So the revenue regression ended up being nice results. Now, what I want to show is some of the data. Here's the actual movie data that we were using, and we put together this graph to show some of the analysis of that data. So what you're seeing here is the net inflows, the one-year returns versus the sequels, the first movie versus the sequels, the averages, and then the inflation rate discount rate. So to start out with, we had to build the negative cost for the present value of year 0, and the formula to do that was, we got the negative cost amount, and we divided it by the negative cost amount multiplied by the semi-annual inflation rate, and then also multiplied it with the semi-annual discount rate. And so that ended up having the negative cost amount, ended up being positive, and it had good results. But when we did it in present value of year 3, we had to add in a few other numbers, a few other significant data as the power of 6. We put the power of 6 when we multiplied it with the semi-annual inflation rate, and then we divided it 2 plus the negative cost amount of the semi-annual inflation of the power of 7, and we divided that by the semi-annual discount rate to actually get the negative cost of the sequel of present value of year 3. And those also end up being higher as we wanted, obviously, because it was year 3, than the present value of year 0. And then 1 year return, that's it's just simple. All you're doing is the negative inflows of present value of year 1 minus the negative cost of the year 0, and you divide it by the negative cost, and so you get the 1 year return. And to analyze the 1 year return, what you want to see is how the first movie, a lot of these numbers here are positive, but then on the sequel, a lot of them end up being negative. So when you're looking at the average, you can see that the average is the 1.11 versus the 0.28 the 1 year. So the overall average ended up being even higher than the 1 year analysis. And secondly, the other average we want to talk about is the inflows. The 31.12 of the inflows present value versus the present value of year 4 of the inflows and sequel. What that signified is, look how higher it is even on the first movie, mainly because the sample 6 movie will end up being so much higher than all the others combined, averaged out, made it a higher number. But it's still significantly significant because the net inflows of year 1 was even higher than of year 4. So, thirdly, the net inflows of standard deviation I want to show right here of the present value of year 1 was also higher than the present value of year 4. So that's another significant statistical significance on that number. The other main thing I want to show is how the sample 6 compared to sample 14. If you look here, the data of the difference between the inflows and the cost, see how that's such a huge amount. And comparing that to the sequel, those are also pretty huge. But then when you look at 14, you see how the 14 data was just the opposite. It was a lot lower on the year 1 versus the year 0, and then also the sequel of year. So the data was consistently different, which was really good. We wanted to get a lot of different data and different sample movies to build our overall statistical analysis. When you're not even comparing this, but all the other data that we were showing in the previous graphs.